Welcome to the presentation from the 3 idiots at ScaleGenAI. Full disclosure, we have not put any effort into making these PowerPoints. All of it is stolen material by using a RAG-enhanced large language model. So you will see a lot of hallucination in those slides. Second is, we are hopelessly biased towards open source. Not because we believe in freedom, not because we believe in cost, just that's how we make our money. So I'll be very honest in saying that open source is the way to go. This is just, the decision is made, this is just a justification of the decision. Now, I've been in the industry since 1999, and I've kind of, for the first open source versus commercial war, which started in 2001, that time it was Linux versus Microsoft. Not many people know that Linux as a server operating system, which we just take for granted these days, really came in, the first version came to being in the late 2002 timeframe. In 2008 or 2009, it was about 20% of the market. Microsoft Windows was close to 70%, and the rest of the players who didn't matter were 10%. And if you look at it by 2016-17, I think Linux has crushed every other competitor in this space. It's all open source, all open source. And the way I see it is, what you're seeing is the same thing playing out. It's just a function of time. That's, again, I'm hopelessly biased. It's just a function of time that in the next 2-3 years, open source language models, open source LLM multimodal models will account for, I would say, more than 90% of the AI that gets deployed in this particular space. Of course, whenever they say when you do a Shubhkam, you're supposed to pray to the gods. He's the god of AI, and he's got a very valid point. He says, why pay for someone's 1.1 billion parameter model when a 7 billion parameter model tuned to my data can do the job equally? Which is a very valid point. Now, here's a fun part. I mentioned the fact about the Linux versus Microsoft war. It started in 2002. Linux reaches 20% of the market by 2008, and by 2016-17, it's pretty much the dominant server OS. All the innovation is happening on Linux. The fact that Microsoft Azure by 2014-15 realized they had to support Linux because they accepted that Linux had won that server war. The same thing is playing out in the language models world, but now that years are actually now days and weeks. It's crazy to see the guys at OpenAI come out with an improvement, and the folks at Llama or Mistral putting an equal improvement on their torrent that evening. It's almost like people are calculating times in hours and sometimes minutes, how quickly they can respond. So what you saw happening over 20 years between Linux and Microsoft is going to get played out, or is already getting played out in the last 1 year. You saw the first version of Llama 13B, you really couldn't compare it to GPT. Okay, and given it a few months, with all the improvements that came to it, with Llama 2, it's pretty much getting close to what ChatGPT was getting to. Now, this is one of the reasons, and I would say this is the biggest reason why open source models will prevail. And again, this is not bias. I think I'm quite right about this. Being in this industry for 24 years, I think I'm right about this prediction. And therefore, there are really 2 reasons. One is, and I'm going to give you another parallel. Again, a lot of you here are in your 20s, so most of you have not lived in the world where there were no open source databases. MySQL came again, mid-2000s. MongoDB came in 2009. Now, at that point of time, the only real architecture that existed was relational databases. Oracle, SQL, and IBM DB2. For those who are old enough, you'll remember those days. That was the only, even when you did any kind of database, you had to write them in relational queries. All right. Come MongoDB, come vector stores, suddenly see a variety of new database architectures. It's not that these database architectures didn't exist in the commercial world. The problem was the commercial business models, or the commercial R&D model, didn't create a viable market for these databases, which were not conforming to the relational standard. Oracle's marketing or Microsoft's marketing was so strong that even if you had a great object database, at that time a vector database was called an object database, for those who are familiar with that term. Those companies were wiped out. All these object database guys were wiped out by just very good marketing from the big relational database players. That's not happening in the open source world. What happened in the open source world today is, yes, there are relational databases, but they're vector databases, they're object databases, they're document databases, they're in-memory databases. So there's a large variety of architectures which float around. Now, fundamentally, the way software gets built in the commercial world is you commit to an architecture and you improve upon that architecture. Very rarely can you see a commercial company putting money and building good products in 10 different architectures. But what you need in the AI world are 10 different architectures, because not every problem fits a particular architecture. Now, this is a very good example. I'm just giving you a very small example, 2 examples. You should check these guys out. It's a company called defog.ai, 2 very smart Indian engineers. They've essentially fine-tuned, which I feel is a Llama model, and built a specialized model which can generate SQL. And it does a fantastic job at it. You don't, I hate to say this, if your core competence is writing SQL, look for changing your career, because in a year's time, this will do a much better job than most SQL engineers can do. And again, it's 2 engineers who built this. This is open source. It's a 70 billion parameter model, quite a commercially viable model to work on. And what I have on the right is another example of where open source will beat the bigger boys. And that's the fact that, again, the open source players have committed to an architecture. They're going to stick to that architecture. It's not very easy for them to, in the same company, run 10 different architectures. It doesn't work. ByteDance, and I still not understood the algorithm, so don't ask me to explain, but ByteDance came up with a very interesting way of using reinforcement learning for fine-tuning Llama models for pure reasoning problems. They figured out that basically language models are not very good reasoning engines. Like if you want to ask it a mathematics question, it really doesn't understand it too well. So they came out with a reinforcement-based fine-tuning technique. It's computationally actually very effective, very, very efficient. I said, I still don't know how it works. I read the paper 4 times. I'm still confused. But basically, this is an example how you're going to have in the open source world a variety of specialized models, a variety of specialized approaches, whether it's on inferencing, fine-tuning, training from scratch, which the commercial world will not be able to match. That's my prediction. And that's why I say that when we are at MLDS 2026, I think a presentation like this will not get no audience, because it'll be like a foregone conclusion that 90% of the world is on open source models. So now I'll stop, and I'll hand over to Aman and Kartheek. Again, full disclosure, they have not done any effort. This was all LLM RAG-generated slides, and that's why they're terrible, and they're terrible speakers, by the way.
All right, so we started off on a bit biased note towards the open source models, and I'll make sure this continues. So now let's talk production. Now, you have $1 million app idea, and you want to take it to the market ASAP. Now, me being in product management, I get to talk to a lot of customers on a daily basis. This can be startup owners, people working in the software industry, some of these directly working with generative AI, and some of these are just service providers. So while talking to them, the conclusion that I came to is that the easiest way to take your AI app to production is by using the proprietary commercial AI APIs. Now, Google's Bard, OpenAI's GPT, or Anthropic's Claude are one of the most easiest options in the market available right now. For you, creating an AI app is as simple as just picking up a base model. For example, let's say the OpenAI GPT. Now you fine-tune this model on your own data, and your AI app is ready to be taken into production. As it lands into production, you're going to collect some data, you fine-tune this base model on top of this data, and this cycle continues. Now here, we are under the impression that your business model is going to operate on top of these commercial LLM APIs. This has several pros and cons associated with it. So let's first talk about the pros. So the first and the most biggest advantage here is the easy POC setup. So setting up such an environment is simply very easy. You don't have to make any infrastructure decisions. You don't have to set up anything up. You don't have to do any networking or all of those nitty-gritties. For you, it's as simple as just picking up a base model. You get constant updates. You get constant updates in terms of security, the performance optimizations, in a completely managed suite. For you, it's as easy as calling some inference APIs, just like that. But it has several downsides to it. The biggest one is being the huge operational costs. So as you operate, as your user base increases, slowly you'll find that your workload increases as well. And this simply translates to higher operational costs. If you're a startup just in growth stage, this can eventually even kill your business. The second biggest problem here is the slower innovation cycles. So a funny thing here, you are essentially relying on OpenAI's product roadmap for your application's performance, right from the model architecture to whatever internal fine-tuning methodologies they are using. You control nothing. The entire control relies with these commercial LLM API providers. Now, one of the biggest problems in this case is you cannot guarantee a service level agreement. You're essentially relying on a shared infrastructure. You're sharing whatever compute that you have with a lot of other users. A lot of these commercial LLM service providers, they rate limit you. If they're not rate limiting you, like I said, you're still operating on a shared compute service. So in the future, as the workload increases across the industry, there's a high probability you won't be able to provide a consistent throughput for your application. Now there's one way to solve this problem, which is something known as provision throughput. So provision throughput is a service a lot of these commercial LLM API providers provide to you. This is an expensive add-on on top of your existing subscription. So that basically guarantees you a consistent throughput. Now, we did the hard work of going through the documentation for Azure OpenAI's provision throughput, and there you find this very interesting topic called quota. This basically says that your compute, whatever compute that's available to you, that is bound by some quota restrictions. So if you're a startup, just getting started in the business, and you don't have the quota limits that these very big companies have, there is a probability you don't even have access to this provision throughput feature. So simply saying, definitely, these commercial LLM APIs are great in case you just want to launch your POC. But as you operate, as you go into production later on, you'll find that this is not a viable option. Now, Kartheek will take over.
Hello? Okay, great. So let's talk open source now, right? So let's all hallucinate a bit more together. So in the open source model approach, usually what people do is start off with a proprietary AI API, and then you collect your data on the side, and then you would eventually transition over to an open source model. Now, there is also another new trend that's coming up where people would actually use the open source model to begin with, but actually use GPT-4 as their, let's say, as their validation mechanism to kind of skip your manual validation. You can do something like that as well. Now, how does this work, right? So at the moment, if you think about how you would fine-tune your model when you're using OpenAI, it's just one endpoint, /fine-tuning/start, or something like that, right? So compare that to, say, you want to set up a web server today. Like, you wouldn't call somebody in AWS and say, like, okay, I want an EC2 instance, give it to me with Nginx, right? So some companies still do that, no offense to them, but it's going to be a lot more diverse, and there are a lot of tools to pick from. That's what open source brings to the picture, right? So it's not just about accuracy, it's also about a lot of options that you can have to kind of build your solution in your own way. Now, as Aman and Akash have pointed to before, if you have your own fine-tuning pipeline, you get to slot in and slot out these custom mechanisms that are coming out day after day that are very good for your specific business use case. So you don't have to be at the mercy of OpenAI or any of these bigger providers to let them support your business-specific use case, and you're sitting duck till they do it, right? So that's a good advantage you have. And also, to draw a little more on the Linux and Windows comparison that we've spoken before, in Linux, if you take each individual component is actually implemented by different people, right? So your audio driver is Pulse Audio, your display is X server. These are each individual parts that come together and make your Ubuntu server today, right? Now, you can always make the argument that Linux is only free if you don't value your time. But as Akash has mentioned, I have never seen somebody deploy their web server on Windows since I was born. So you can see that as time goes on, eventually things like Nginx and Grafana, which have evolved to a level where they are just set and forget, and all of them being powered by open source, it's not so bad to expect the same from the LLM open source community, is our position. Now, let's zoom in a little more on how would you actually do the training in these both approaches, right? So when you're training with GPT-4, the data that you require is very, very low, because this is a trillion parameter model, so you can do what's called few shot learning, so your data set that you want to curate can be very small, as opposed to fine-tuning or training from scratch, where you have a lot more data, because your open source models are smaller and they require more data. But we can see that with each new data point added, the performance of fine-tuning is way up there compared to OpenAI GPT, because there is only so much optimization you can do with your limited data, right? So essentially what fine-tuning is, you're modifying a certain layers within your model. Now, within a trillion parameter model, it's hard to find that one local minima, which is a niche use case for your business, right? So it's a very hard problem to solve. So you might have to train epochs for years, and OpenAI will happily bill you, it cost an arm and a leg, basically. Now, compare that to fine-tuning. You take a small model like Meta Llama 2 7B chat or Mixtral or any of these open source models. As you grow, as your GenAI team grows, as your data ingestion becomes better and better, you can see those gains directly in the performance as opposed to things like OpenAI, GPT, or any of these proprietary LLMs. Now, I'll just let Aman pick up this one.
Yeah. So the deployment cost over time is where the stark difference between fine-tuning your open source model or using ChatGPT or the commercial LLM APIs actually comes into the picture. So if you take a look at the beginning, the setup cost for something like OpenAI GPT is very small because these models have been trained on a large corpus of data. They tend to be very huge in size in terms of parameters, and they are able to perform different kinds of tasks. So there's a good probability you can launch your app without even having to fine-tune your data, your model initially on your data. Compare that with fine-tuning or training from scratch. So there are some initial setup costs involved. This can be in terms of the data procurement fee, or this can also be the setup required for training your models. But over a period of time, as you notice, the hefty fee that you're paying for your commercial LLM APIs managed service, this soon surpasses whatever initial setup cost that was involved with fine-tuning your model or training it from scratch. So over a period of time, you'll notice that fine-tuning or even fine-tuning and coupling your model with something like RAG is much cheaper as compared to something like using OpenAI GPT in the longer run.
So switching gears, I want to talk a little bit about what happens after you've deployed your model into production, right? So an LLM endpoint and an API endpoint that you have, whether it's OpenAI or your own deployment endpoint, is no different from any other endpoint that your web services have, right? So you need to dedicate the same level of site reliability engineering, metrics, logging, observability, all that good stuff for these endpoints. But since there are LLM endpoints, they're special in their own way, you also have to do a lot more monitoring with respect to things like prompt injection and jailbreaks, so that you make sure that people don't peep inside your model and make it do weird things. The number of examples where people have made LLM do rogue things and give out cars free for $1 on the customer chat support is so many that almost it can have its own subreddit. So there is no subreddit, so if anybody's interested in moderating, you can create your own subreddit, call it LLM fails, right? And you can document all the prompt injection and other failures. Now, jokes aside, the point is that LLM endpoints require a lot more babying, if you will, because they are susceptible to all these kinds of jailbreak issues, which are not yet fully understood by the industry itself. So there's an ongoing effort continuously that happens, and you have to keep track of these attack vectors and keep fixing them constantly. Yeah, I'll let Akash take over from here.
So Kartheek and Aman asked me to give a very detailed comparison where you should basically use commercial LLMs and where you should use open source. I'll try to make it very simple. I don't like long answers. If you're lazy and you have a lot of money, the option on the left is great. If you're innovative and like to save cost, the option on the right is great. Everybody here is an Indian, and as an Indian, I don't think there's any one of us who doesn't like to save money, right? So short answer is, and I'm going to make a statement that a lot of people who work in commercial LLMs don't like, but heck, I've been in this business 24 years, I can afford to offend few people. Use commercial LLMs as your debugging and validation tools. Build your own open source models, send the same query to your custom design model, send the same thing to GPT-4, keep fine-tuning until your model gets better for your particular use case. Yes, so that's basically a short comparison. Now the folks at MLDC told me that I could indulge in 2 minutes of shameless self-promotion about what ScaleGenAI does. As an entrepreneur of 24 years, I'll tell you that the biggest strength of entrepreneur is not hard work or vision, it's being shameless and fearless. So for a few minutes, I'll be shameless here. So what does ScaleGenAI do? Okay. How many of you were born when Google started in 99? I think probably a very small portion of this audience. Okay, so I think there are only 2 of us, so, all right, okay. So, I at least had a career in IT when Google started in 1999. How many of you think Google is a great search company? Come on, guys, I need some participation. Okay, great. I disagree. Google is a great infrastructure company. The PageRank algorithm of Google was actually invented even before the guys at Google figured it out. Google's biggest innovation was, at that point of time, finding ways to use cheap computer hardware rather than, look, that time, multi-core CPUs didn't exist. Solid-state drives didn't exist. Memory was in kilobytes and megabytes. I know it sounds a bit like I was born in the dinosaur era, but that's what life was in 99, basically. All right. So the folks at Google hired this entire team from companies like DEC, that time digital equipment, guys who were really people of my age, who knew how to program an assembly, write operating systems, and said, okay, we have all this cheap used hardware. Let's find a way to string together tens of thousands of these machines and build a search engine, while everybody else used to buy these expensive servers from companies like Digital Sun. These companies don't even exist any longer, to basically build their. Yahoo did that. Yahoo was selling Sen servers. Okay, that's why Yahoo search could never scale compared to Google. So Google was a great infrastructure company. If you ever look at OpenAI, ever go to OpenAI's LinkedIn page and start looking at the profile of their engineers. For every one smart AI engineer, there are 4 engineers who are dealing with GPUs, kernel optimization, CUDA optimization, operating system versions, failure handling, cloud security. So even running an LLM, infrastructure is a very important point. It's like saying, I want to drive a Ferrari. You can't drive them on Bangalore roads. The roads don't exist to drive them. Good software needs good infrastructure. It needs good hardware, it needs good infrastructure. And that's what we've tried to do at ScaleGen. Of course, this was just to further talk of, Kartheek, myself, and Aman did some work over the last 2-3 months and said, let's look at all the open source projects which are there, which do in some way improve the performance of the LLM. I'm not meaning in terms of accuracy, but in terms of for the hardware that you have, what can give you more tokens per second. We found 33 different projects, each with their own interesting good ideas, basically on how you can increase the throughput that you got. So we found basically models which on a particular NVIDIA GPU model gave you 60 or 80 tokens per second on, say, a 70B parameter model. The moment you start adding all these little improvements, you could take the performance to almost 4 or 5 times of that. But the problem was these things don't work well with each other. So infrastructure optimization is a large portion of running an LLM. There's a reason that NVIDIA says, or NVIDIA has projected to the financial community that they're going to be generating $100 billion, 100 billion with a B, of free cash flow, not revenue, free cash flow. And all that is coming from AI, and a large portion of that is coming from LLMs and multimodal LLMs, because these things are computing guzzlers. First time in the tech business I've seen where software is eating computing power so quickly. And we don't see the problem getting resolved because silicon scaling has also hit a wall. Earlier, basically, chip designers, including me, we could basically double our performance just because the manufacturers, the chip designers, every 2 years, the process node kept getting better. No longer the case. Why we went from 90 nanometers, we're down to 2 nanometers. Once you go down to 1 nanometer, you're getting to quantum entanglement effects. You can't make chips faster anymore. So all the innovations come from software. So what are basically we doing at ScaleGenAI? Well, we have a very simple idea. In this room, I know there are a lot of entrepreneurs and business owners, and a lot of future entrepreneurs and business owners. What if you wanted to build your own OpenAI? Not OpenAI with the goal of making a ChatGPT-like board application, but you have an idea of a smaller application which needs to use a language model or in the future, a multi-language model. So we came up with a thought process saying that there are about 17 cloud providers worldwide. There are more than 250 data centers, close to 280 of them, which have spare GPU capacity for a few days and few hours. So we said, let's do this. Let's build software which can run inside a cloud, which can connect to all the spare GPUs in the world, and we allow everybody, and we give everybody their own private API endpoint, which is OpenAI compatible, but allow you to basically build your own scalable LLM or multimodal LLM service by connecting to this massive GPU computing network. And we can do this with almost, I would say 20, 30 second additional latency, millisecond additional latency than you will see when you use OpenAI or on Anthropic or Gemini from Google. So our goal is basically with this, and The last decision we took, we said, is we're going to allow this to be white labeled. Nobody needs to know who ScaleGenAI is. Anybody who's building an LLM or a multimodal LLM app puts this, it's your brand, Scale LLM. Think of us being that below the water. We like to stay below the water. Right? So that's what basically ScaleGenAI is. And our goal is basically, yes, you could start with your LLM with as small as 1 GPU, and within 10 seconds it could scale to 250 GPUs with the capacity, if the load on your system goes up that quickly. That's how sophisticated the system has become. So I'll skip all this. Thank you so much.